Hi, this is Stan Lyle with MasterMath. During the lesson, you're going to come to some You Try It slides where you're asked to do problems that relate to the lesson. Hit your pause button, try the problem, and then hit the forward key to move on to the answer. I hope you have a really good time today.
Today's lesson's on solving absolute value equations and inequalities. And before you finish this lesson, you'll understand absolute value, you'll understand absolute value equations, and also absolute value inequalities. You already know what absolute value means. Absolute value is just the distance of a number to 0 on the number line. What's the absolute value of minus 6? Well, we plot minus 6 on the number line, and then we find out how far it is from that point to 0. The distance between minus 6 and 0 is 6. So the absolute value of minus 6 is 6. All right, well, let's push this a little bit further. You know that the absolute value of 5 equals 5, and you also know that the absolute value of negative 5 equals 5. Both 5 and negative 5 are 5 units away from 0 on a number line. Well, what if we ask you to solve for x in the equation the absolute value of x equals 5? If you're smart, you can see that either a value of x of 5 or a value of x of minus 5 would satisfy this equation. X could equal 5 or x could equal minus 5. How about this one? If we said that the absolute value of x minus 4 equaled 6, and ask you to solve that for x, how would you do it? Well, because it's an absolute value, because x minus 4 is an absolute value, then x minus 4 could equal 6, or x minus 4 could equal minus 6. Now, we'd want to solve both of those equations to figure out what x could equal. Let's start with the one on the left. X minus 4 equals 6. To solve that, I'm going to add 4 to both sides of the equation. And now it reads x equals 10. So that's a solution. But there's another solution. X could also equal the solution to x minus 4 equals minus 6. And to solve that, again, I'm going to add 4 to both sides of the equation. When I do, I get x equals minus 2. So, the solution to the absolute value of x minus 4 equals 6 is either x equals 10 or x equals minus 2. You try this one. Hit your pause button, try the problem, and then hit your forward key to move on to my solution. Well, if the absolute value of x minus 1 equals 2, then x minus 1 can have two values. X minus 1 could equal 2, or x minus 1 could equal minus 2. Now we need to solve both of these. And we're going to solve them both by adding 1 to both sides of the equation. On the left, where we've got x minus 1 equals 2, when I add 1 to both sides of the equation, I get x equals 3. On the right, I add 1 to both sides of the equation, and I get x equals minus 1. So, either an x value of 3 or an x value of minus 1 satisfies and is a solution to the equation the absolute value of x minus 1 equals 2. Now, if you ask me, this is a fairly complicated concept, and at this point you may want to go back to the beginning of the slideshow, the beginning of the lesson, and watch it again. if you watch it 2 or 3 times, I think it'll start to come together, and I think you'll understand it. Well, I just explained that this was a complicated concept, and now I'm going to make it even more complicated. Holy cow, look at that. 4 times the absolute value of x minus 2 minus 3 equals 5. That's confusing as can be. Well, let's simplify it. Let's try to make it look a little bit simpler. I want to get rid of everything on the left side of the equation except for the absolute value of x minus 2. That means I got to get rid of a minus 3, and I got to get rid of a 4 times. Now you have enough algebra background to know that I want to get rid of a plus or a minus first and then deal with the multiplication and division. So I want to get rid of that minus 3. To do that, I'm going to add 3 to both sides of the equation, and I'll get 4 times the absolute value of x minus 2 equals 8. Now I'll get rid of that 4 times. I'll divide both sides of the equation by 4. And when I do, I get x minus 2, or the absolute value of x minus 2, equals 2. Now that's much simpler and much easier to deal with. And I know that since it's an absolute value, there's 2 potential solutions for x minus 2. X minus 2 could equal 2, but x minus 2 could also equal minus 2. Now I need to solve each of these 2 equations. The first one, I'm going to add 2 to both sides of the equation, and I'll get x equals 4. And the second one, I'll add 2 to both sides of the equation, and I get x equals 0. So, either an x value of 4 or an x value of 0 will satisfy the equation 4 times the absolute value of x minus 2 minus 3 equals 5.
Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer.
Well, we definitely need to simplify this expression in order to solve it for x. So I'm going to get rid of minus 4 first. I'm going to add 4 to both sides of the equation, and that'll get rid of my minus 4 on the left side of the equation. Now I'm going to have to get rid of the 2 that's being multiplied by the absolute value of x plus 3. So I'm going to divide both sides of the equation by 2. And after I've simplified all of that, I get the absolute value of x plus 3 equals 5. Now, I know that any absolute value has both a plus and a minus answer, so I know that x plus 3 could equal 5, or x plus 3 could equal minus 5. I need to solve both of those equations by subtracting 3 from both sides of the equations, and on the left I'm going to get x equals 2, and on the right I'm going to get x equals minus 8. So, either an x value of 2 or an x value of minus 8 would satisfy the equation 2 times the absolute value of x plus 3 minus 4 equals 6. Well, now let's talk about absolute value inequalities. And I want you to think about this. If I were to say that the absolute value of x is greater than or equal to 4, I could re-say that a couple of ways. I could say the absolute value of x is at least 4. And I could also say that the distance between x and 0 on a number line was at least 4. Well, let's look at a number line and see what that looks like. One way to satisfy this inequality is to say that any number bigger than 4 satisfies it. 4, 5, 6, all those numbers to the right of 4 are at least 1, 2, 3, 4 units from the origin. So, any value of x that is at least 4 satisfies the inequality, the absolute value of x is greater than or equal to 4. However, because it's an absolute value, there's going to be an answer on the negative side of the number line that satisfies this as well. And I can see that any value of x that is -4 or smaller, any value to the left of -4 is at least 1, 2, 3, 4 units from 0. So, any value of x that is less than or equal to -4 also satisfies the inequality, the absolute value of x is greater than or equal to 4. And I can combine these two expressions and say that x is greater than or equal to 4, or x is less than or equal to -4. X is at least 4 units away from 0. How about this one? The absolute value of x is less than 4. Well, that means that x is less than 4 units away from 0. X is close to 0. It's not further than 4 units away from 0. So if we graph this on a number line, the answer would include all those numbers that were less than 4 units away from 0. And we could write it this way. We could say that x was less than 4, so all those values less than 4, but we could also say that x was greater than -4, all those values to the right of -4. And we can combine those. First of all, to combine them, I'm going to change this. I'm going to turn it around and make it read -4 is less than x. Now I'll just combine those two, and I've got x is greater than -4, but less than 4. What if I had the absolute value of x minus 3 was greater than or equal to 5? Again, I'm saying that x minus 3 is at least 5 units away from 0. And I know that I can rewrite this into two expressions. Because it's an absolute value, there's going to be a positive and a negative value for the right side of the expression. So I can rewrite this as x minus 3 is greater than or equal to 5. But I could also write it as x minus 3 is less than or equal to -5. Now I need to solve each of these equations, or each of these inequalities. I'll solve the one on the left first. I'm going to add 3 to both sides of the inequality, and I'll get x is less than or equal to -2. Now I need to solve the right side. I'm going to add 3 to both sides of the inequality, and I'll get x is greater than or equal to 8. And if I were to graph this, I've got two numbers that I need to graph. I need to graph x values that are less than -2 and x values that are greater than 8. Now, when you've done a complicated inequality like this, you may want to test some numbers to see if it really works. And let's test several of these. Our number line says that 0 is not in our solution set. 0 is not in the solution set. Well, let's try it. Let's substitute 0 for x. I've got 0 minus 3, which is -3. Then I've got the absolute value of that, so it's +3. Is +3 greater than or equal to 5? Well, no. So it's not part of the solution set. But if I try -5, it will work. -5 minus 3 is -8. The absolute value of -8 is 8. 8 is greater than 5. So 8 is in my solution, or -5 is in my solution set. How about 10? 10 minus 3 is 7. The absolute value of 7 is 7. 7 is greater than 5, so 10 is in my solution set. Well, here's an absolute value inequality that looks a whole lot more complicated, and it is, but all you got to do is simplify it. In this case, all we got to do is get rid of that 2, so all we have left on the left side of the inequality is the inequality, absolute value of 3x plus 2. And to get rid of a 2 that's being multiplied by something, I want to divide both sides of the inequality by 2. When I do that, I get the absolute value of 3x plus 2 is less than 5. Now, it's an absolute value, so that when I convert it, I'm going to get two equations, or two inequalities. I'm going to get 3x plus 2 is less than 5, but I'm also going to get 3x plus 2 is greater than negative 5. Now I need to solve both of these inequalities. Let's start with the one on the left. If I subtract 2 from both sides of the inequality, I get 3x is less than 3. Now I need to divide both sides of the inequality by 3, and I get x is less than 1. Let's go over and work on the right side. If I subtract 2 from both sides of this inequality, I get 3x is greater than minus 7. Now if I divide both sides of the inequality by 3, I get x is greater than minus 2 1/3. So I've got two solutions. X is less than 1 and x is greater than minus 2 1/3. And I can combine those because x is less than 1 and greater than the other. I can combine those as x is between 1 and minus 2 1/3. Well, there's really only two alternatives when we talk about absolute value inequalities. Either the absolute value of x is greater than b, or the absolute value of x is less than b. Now, for greater than b, I could substitute greater than or equal to and it wouldn't change anything. And for less than b, I could substitute less than or equal to and it wouldn't change anything. But just to simplify this, let's think about the absolute value of some number x is greater than some number b. What's that mean? What's that greater than mean? Well, what it means is that x, the distance of x from the number line, is greater than some number b. X is further away from 0 than b units. In the other case, I'm saying that the absolute value of x is less than b. And that means that the distance between x and 0 on a number line is less than b. X is near 0, and it's not further away from 0 than b is. Let's look at a number line, and maybe this will be easier to understand. In the first case, I've got the absolute value of x is greater than b. That means that x is further away from 0 than b units. Well, that could either be positive b units or negative b units because we're talking about absolute value. Any number that's less than minus b would satisfy this inequality. But also, any number that's greater than b would satisfy this inequality. So there's two different solutions. Either x is less than minus b or x is greater than b. The other alternative, again, is that the absolute value of x is less than b. That means that x is nearer to 0 than b units. X is closer to 0 than b. And if I were to graph that, any value that's closer to 0 than b would satisfy that inequality. And I could write that this way. I could write that as x is greater than minus b, but less than b. So, if you're dealing with a greater than inequality or a greater than and equal to, you're going to have an or sign because there's a section to the left and a section to the right that both satisfy the inequality. But if you're dealing with a less than inequality sign, then it's going to be just a region that's closer to 0 than the number on the right side of the inequality. And you can write this as a single inequality without the or. You try this one. Hit the pause button, try the problem, and then hit the forward key to move on to the solution. We're asked to solve and graph this inequality. And the first thing you want to look at is that greater than sign, because that greater than sign means that I'm going to have a split answer. I'm going to have two different answers. I'm going to have an answer on the left side of the number line that satisfies this, but I'm also going to have an answer on the right side of the number line that's further away from 0. So there's going to be two solutions separated by an or. Now let's simplify this. First thing I want to do is get rid of the 2 on the left side of the inequality. So I'm going to subtract 2 from both sides, and when I do, I get the absolute value of x minus 4 is greater than 6. Now, I know that because it's an absolute value, there are two potential answers. The first is that x minus 4 is greater than 6, but it could also be that x minus 4 is less than minus 6. Now I need to solve both of these. And in both cases, I'm going to add 4 to both sides of the inequality. On the left, when I add 4 to both sides of the inequality, I get x is greater than 10. And on the right, when I add 4 to both sides of the inequality, I get x is less than minus 2. So my answer is x is greater than 10, or x is less than minus 2. And when I graph it just like this. X is either greater than 10 or it's less than minus 2. That's a lot of material and it's a little bit confusing, so you may want to go back and look at this video again. And by all means, go to www.mastermath.info, and there you'll find some worksheets and quizzes that will help you master this concept even better. Well, I hope you learned a lot. I hope you had a good time, and I hope we see you again real soon.